Welcome back to Chain of Thought, everyone. I am your host, Connor Bronston, head of technical ecosystem at Modular. And today we are talking about something every AI product team is wrestling with right now. When do you fine tune? When do you use frontier models? And how the heck do you make these decisions when everything changes quarter by quarter, if not week by week at times with some of these recent model releases? My guest today is Fergal Reid. Fergal is the chief AI officer at Intercom, where he has scaled their AI team from just 10 people to 55 in about 2.5 years, and planning to double that team size again next year as they continue to heavily invest in AI, including with their agent Finn, which we'll talk a bit about. But what makes this conversation particularly valuable is that Fergal and his team have completely reversed their position on a fundamental strategic question. Just 2 years ago, Intercom's take was relatively simple. Look, frontier LLMs are improving so fast, we don't really need to spend that much time fine-tuning. Just get really good at prompt engineering, providing context, and ride the wave of better models. Today, they've instead heavily invested in post-training and fine-tuning open-weight models, with fine-tuned Qwen models running at scale in production, replacing GPT-4 for key tasks and saving significant money in the process. So what changed? How did Intercom and Fergal make these decisions? And what does that tell us about where the industry is heading? Fergal, welcome to Chain of Thought. It's great to see you.
Thanks for having me, Connor. Delighted to be here.
Yeah, I think this is going to be a really fun conversation because often in these talks, we don't focus on a use case and really talk through the trade-offs that are made along the way as much as I think we ought to. It's very common, and I think listeners will tell me this occasionally, like, hey, look, this is maybe a little too high level. Like, you just talked about like what's exciting, what's interesting, and those are conversations can be useful, but I think it's important to drill down and really explore why decisions were made at a company like Intercom, and I think it's going to be a fascinating test case. So let's just start with that elephant in the room. 2.5 years ago, your position was essentially don't bother fine-tuning. The frontier models are improving too fast. Focus elsewhere. Now you have, as we said, heavily invested in post-training open-weight models. Walk me through what changed your mind. How did you get to where you are today?
Yeah, absolutely, Connor. So things really changed out there in the external world. So again, 2.5 years ago, we were just starting to build Finn. And we were building Finn initially with GPT-4, GPT 3.5 at the time. It didn't follow instructions as well. It used to hallucinate more. And really, GPT-4 was this threshold for us where we could give it instructions to try and constrain it to just answering in, from text that a business customer of ours controlled, which everyone calls RAG now. And so, that was really we were very early to that. And there was really so much to do at the time by just getting better and better at prompting these large models. Like the difference between a badly prompted GPT-4 and a very well prompted with a well-engineered prompt, night and day in terms of the actual performance, in terms of the actual accuracy. And so there was just this period of time for maybe a year and a half, where models got better so fast. They got cheaper, they got more efficient. We had models like Sonnet came along, Claude Sonnet 3, 3.5 came along, really much better at like following instructions. And we could do a lot more by just getting very good at like prompt engineering, tuning, back testing, building more and more into the core prompts. And at the time, there was other people in the space talking a lot about training their own models, or maybe taking a model and, post-training or mid-training with this like mix of data curated for their specific area. And we looked at that and we did a few experiments. I remember we ran an A/B test with a fine-tuned version of, I think it was Text DaVinci 3, one of the GPT 3.5 kind of turbo models. We ran experiments with fine-tuning. We fine-tune models like in the GPT 3.5 kind of turbo series. And we did A/B tests in production of those, but we just didn't see the improvement overall, versus instead just getting better and better at like taking these models and just getting better and prompting them. And so that was really the case for a long time. We made this very deliberate decision. No, we're not going to invest a ton of money and time into fine-tuning your own models. We're just going to piggyback on this wave of, it felt like every quarter or 2 quarters, there was a new leading frontier model that was dramatically better at customer service and at the sort of things we wanted to do. And really in the last sort of 6 months, 9 months. That's kind of changing. Now, I do think the frontier models are continuing to improve and they're getting better and better at like being agentic and following instructions. But in our area, our domain of customer service, let's say for our core RAG tasks, the models, it feels like they're saturating the intelligence level that we need for that core task. And instead, what's more important to us is really fine-grained control over when the models do and don't behave in certain ways. So one thing we care a lot about at Intercom is, with Finn, is when should you escalate? When should you say, hey, I want to involve a human in this? And that's something that we care a lot about, very fine control over. And so we spent a long time, hand engineering our prompt with like certain times when you should escalate and when you shouldn't, giving customers even the ability to provide guidance to that. But we've been able to get a level of control over and above that again by actually post-training and fine-tuning some custom models. And so I really think that like when your application matures, maybe when you no longer need frontier levels of intelligence, it's a good idea to think about doing your own post-training because you can reduce costs a lot and also you can get like much more fine-grained control over the exact policy that the LLM follows. So both of those reasons have been very effective for us.
When did you start to question that original approach that you were taking? Was there a specific moment where you said, actually, maybe we need to change up how we're approaching this? Or was it more gradual, maybe even correlated to simple team capacity growth and the ability to say, oh, look, now we can do both?
It's definitely related to team capacity growth. Now, the causality goes both way around there, which is that like we hire more people because we want to do more post training, and so we do that because we think there's more value to it, there's more upside to it. I would say that like you know around the time of DeepSeek, that was really when the open weight models started to become close to the closed weight models and started to become almost good enough to do some of our core tasks. And so for a long time, Finn underneath the hood, there's the hardest prompt of Finn, which we use Claude Sonnet for in production, which is like that kind of core answer the end user's question. But then there's always been a set of ancillary prompts that are very important to the overall experience that we've had for a long time. And we would always try and run these prompts on the smallest, cheapest, lowest latency model that we could to get the best end user experience. And so for an example of this would be like, when you ask a question to Finn, the first thing we've always done is we've always had an LLM that will try and summarize and canonicalize the query that the end user has asked. And we found it's worth using an LLM to do that before going to retrieval, because end users ask questions in ways that sometimes are, they can be very colloquial, they can vary a lot from person to person, and they can be inaccurate. And so putting it through an LLM to sort of like, hey, can you summarize this query and canonicalize this query before going to the retrieval model in the RAG stack? And the retrieval models are powerful, but they're a lot less powerful than a modern LLM. So kind of doing that kind of the pre-summarization or pre-canonicalization phase has always improved the accuracy of our overall retrieval system, which then in turn, enhances the accuracy of the LLM generates at the end. And we very early on realized that we didn't need to run GPT-4 or Claude Opus or something very heavy like that to do that sort of canonicalization piece. So we were using models like GPT 4.1 to do that, which is, a model that's pretty good kind of cost performance trade-off. And we're spending a lot of money on that summarization task. I don't remember exactly, but it could have been like $250,000 a month on just that summarization task. And so when you're at that, and now you see, the Qwen models are coming out, and the Qwen tree models are very good, and he's a 14 billion parameter Qwen tree model, it's really good. And we were able to go and take that model and train that model, post-train that model to do that summarization task, and able to replace that and saved almost all of that, several $100,000 a month on inference just by doing that one thing. And then we get more fine-grained control over it. So it's probably a combination of, our product maturing, also the gap between the open weight models and the closed weight models for the specific tasks we were interested in closing. And, and obviously the Qwen 3 series of models is an extremely capable and powerful series of open weight models. I think a lot of people are kind of using those in production for those kind of smaller or ancillary tasks.
I'd love to understand more about how you trained these Qwen models to be so effective here. So obviously, we've seen this explosion in open source AI. Particularly, I think DeepSeek has led the way a lot in driving the edge forward. And Alibaba, obviously, with the Qwen models, has done a fantastic job as well, kind of following through there. And it's interesting, I'll say, to see the juxtaposition between open source models coming out of China and then elsewhere, and then how it's just propagating. So that's a whole longer topic we can dive into if we have time. But I'd love to understand specifically, okay, how did you take that open weight model and actually tune it to what you needed for your summarization tasks and other tasks, it sounds like?
It's definitely involved. So we work primarily on Amazon, on AWS, and so we use large EC2 instances, that I think our standard instance at the moment is like one node of 8 by kind of H200. So we got a lot of RAM, and that's kind of we have set up, we have a kind of an AI infra team that has set up a lot of infrastructure to make it easy for a scientist to log in and to run a distributed training job on those large GPUs. And, we went through a process here. We started out experimenting with LoRA and parameter efficient fine tuning methods like that. Maybe on slot, I think we used a lot at the start. But over time, we sort of invested more and more in this. And now we use, I guess, more distributed training. And, most of what we do these days is a combination of full supervised fine tuning, unquantized supervised fine tuning. And then for some of the harder things we're doing as well, we use reinforcement learning, and we have models in production that we've trained. And we found that, GRPO has worked well for us for some of the things we've been able to do. We've invested a lot in doing things like building evaluation models. We've invested a lot in building a resolution model. We care a lot about, has this answer sufficiently resolved the end user query? We've invested in building a resolution model that does a good job at proxying the real signal we get from an end user, whether something has been resolved or not. And then we use that as an input into our reinforcement learning setup. And so our reinforcement learning setup now tends to, it's this multidimensional setup. One thing is the resolution model. Another thing is a whole bunch of things we care about in terms of are you using bullet points, the right amount, not too much? How long is your answer? How short is your answer? And we also use other open weight LLMs as judges as well for part of that too. So we've a pretty sophisticated reinforcement learning setup. Now, the actual, setting up your objective function and stuff is relatively the smaller part of it. The harder part has been just the infrastructure of we probably, if I look at our investment overall, we have a lot of heads in getting good at running these models at scale on AWS, and getting good at that. That's probably the bulk of the investment, although both are important.
But it sounds like the trade-off decision you've made is sure, we've added headcount to make sure that we can run this system effectively. But the feeling is that if you were, say, using GPT models still for these same tasks, not only would the model inference be significantly more expensive, but you'd still would have to be doing this fine tuning to get what you're doing effectively. So I'm curious what has made Qwen in particular work so well for you. I mean, obviously there's the cost perspective. I think that's a huge piece, but it sounds like there are other reasons you're also focusing on the Qwen family.
Yeah, so the Qwen models, I guess we realized pretty early on after the Qwen models came out. Firstly, they benchmarked well, but then whenever a model benchmarks well, you've always got to look at it yourself and try it in some of your own back tests and some of your own evaluations, because some people accidentally contaminate the benchmarks, or some people just
I would argue it's fairly common.
Yes, maybe common, yeah. And then even people who maybe don't, it's so easy for a researcher or a scientist trying to optimize a benchmark to get good at teaching the model how to do the kind of task that's in the benchmark and then suffer generalization failure. So, we saw the Qwen tree models, obviously they had, a ton of tokens through them, so really generous that they were released open weight, because the large training expense to kind of to create them, and then when we back tested them, they worked really well on sort of our standard back tests, and suddenly we were very interested in this, because we were like, these seem like legitimately performant models. And then we started to do production tests of them, and we would always do like, we always like to do a production test of a well prompted but untrained model before we go and then start post training for our thing, just to get some sort of a sense of like, hey, what roughly how good is this? Is it close to what we're trying to do? And yeah, the Qwen tree models performed well on our back test for our simpler tasks. And again, Finn still runs, frontier model, Sonnet 4. I think we're in the process of moving to Sonnet 4 or 5 in production at the moment for the hardest prompts, but for those easier ones, and all that surrounding stuff we find is a major part of the actual performance of the system. The actual, if you look at Finn, Finn is really this kind of this cluster of 10 or 15 different prompts and machine learning systems, and we have improved the resolution rate of Finn from launch. It was about 30%. Now it's heading towards 70. And like the vast majority of that improvement has not been in the core hardest frontier LLM that has improved, and it's been great, but it's been in that surrounding cloud of systems, the retrieval model, the re-ranker model. We built a custom re-ranker. We built that almost from scratch using ModernBERT, our own cost function. That's worked really, really well, trained on a whole bunch of data. And so, over time, we're getting a percentage point here, percentage point there across the 10 to 20 different parts of the system. It really adds up. So, I guess we've been investing in this area for a while. And so, yeah, we were just excited when as open weight models get better and better, and we get the ability to fine tune them and control them, we're excited to see if we can turn that into more resolutions.
And I think I should be explicit here, since I don't know that we stated this earlier. I maybe alluded to it, but Finn is Intercom's fantastic AI agent for all your customer service needs, is what we're talking about here. And there's quite a bit of information on their website you can find about it. Super interesting stuff. I want to bring up one particular thing you said, Fergal, which is this idea of, when a measure becomes a target, it ceases to be a good measure necessarily. Goodhart's law. And I think Goodhart's law is really interesting here, in part because of that contamination issue we alluded to. But I am curious if there are particular benchmarks that you're looking at when you are deciding which models to prioritize. So you mentioned that there's a few of them you look at, as well as some internal benchmarking. I'd love to understand a bit more about how you're evaluating these models and what external benchmarks you're using, and if you're able to share at all, what internal ones.
Yeah. So I mean, in terms of external benchmarks, like everybody else, we look at the model cards that release, and you get some sort of a sense there. But then you also have to worry about like contamination or people like overfitting to the benchmarks. You know, in terms of internally, we have a suite of back tests that we've curated over time, and it includes things like, every time we have a customer that reports a hallucination, we capture that, and then that goes into our back test. So we have a pretty good suite of real in the wild hallucinations that we can use, and we can basically quickly quantify, hey, in a customer support setting, in a RAG setting, is this model likely to hallucinate or not? We have that, and we have a whole bunch of other like quality things. We care a lot about like, how often will the model give an answer to the question, and then we use LLM judges to like, did they get the right answer or not? So we started to build benchmarks and back tests internally like that. But then nothing beats testing in production. We test everything in production. We've done this. This has been our philosophy for years at this point. And what we really care about is like resolutions. And in particular, we tend to run an A/B test in production with a combination. We look at like the soft resolutions and the hard resolutions. And a soft resolution is when, Finn has given an answer, thinks the answer is correct, and the end user hasn't said anything, and Finn has said, do you want to talk to a human if you didn't get what you wanted? And the end user has like disappeared and not said anything. We count that as a soft resolution. And that's just going to happen a lot. People will get their answer. It's customer service. They'll go away. They won't bother thanking the bot. But typically about 30 to 40% of the time, whenever you give an answer to an end user, they will do what's called like a hard resolution, which is where like they will be like, yep, that has actually resolved my question. They'll say something like, thanks. They say, yes, I got what I want. And that tends to be about 30, 40% the rate of the soft resolutions. And that's our North Star. That's our like ultimate ground truth.
And are you using that for RLHF?
Not directly, because it requires a human in the loop. And when we're doing RLHF, it's offline rather than in production. We don't have an open loop RL in production.
Be too risky as far as what you're actually getting back out of it.
We might get there eventually. So it just our workflow is about like take the model, make the model great at what you want it to do, and like that's the context in which we tend to be like tuning these models. So we're evaluating them on back tests, and then we're taking a release candidate and we're A/B testing that in production. So our RL is like, I guess, offline RL, and
I think it's understandable given how broad your data set is and some of the pieces. I'm just curious.
I think there probably aren't that many people doing full RL open loop in production. I believe
That's my take as well.
Yeah, I think maybe Cursor or someone said they were doing it, which was pretty interesting. It makes sense if you've got a very dynamic, fast moving signal that so this is where you get into like bandit algorithms and things like that in the past. If you were running a news site and you were using LLMs to predict, who's interested in what news articles, or if you're running the, X Twitter, if you're running the recommendation algorithm for that, where, it's a very dynamically changing signal, I guess you'd want to do that. But for us in customer service, it can change fast. It can change month on month, but not day on day. And so like an offline model training setup is fine for us. We have, there's other parts of our stack. So like our retrieval model. And, we use in production signals. Like our retrieval model is trained very heavily on direct real user feedback, where the real user is like, that resolved my question. And then the retrieval model learns, yep, this sort of article is good at resolving that question. It's a little bit more intermediate, a little bit more complicated for training our LLMs. But yeah, our gold standard has always been those sort of resolutions. And then we will always A/B test any model before putting it in production. And we check to see like that the soft resolutions have gone up, but also that the hard resolutions don't go down, basically. And we need to avoid building a deflection machine. And so like checking that like the hard resolution rate, at least doesn't decrease and ideally increases. Like basically the ratio of soft to hard resolutions should be roughly constant for every model change. And we've done this for a long time. And, Finn is at significant scale, so we can get very highly statistically powered A/B tests. It's a bit dated now, but just to give you an idea, like when we switched from GPT to Claude Sonnet, that was a multi-million end user interaction A/B test. And, so we're at substantial volume now. Like Finn now is resolving more than 1 million conversations successfully a week. I think possibly good bit over that. And so we're at enough volume that we can just afford to A/B test in production with real end user signals. And I would say that like that is the gold standard, and nothing else comes close. In that like every back test and every evaluation that we've ever built, no matter how carefully we spend on it, it's possible that this ground truth in production deviates from it. The And we care a lot about like a tenth of a percentage point of resolution. So like we need very highly statistically powered testing setups in order to do this. And we just find just the weirdest things happen in terms of like, one great example of this is like latency. Like for a long time, we always believed that decreasing latency would be a better end user experience. We still believe that, but we now know that increased latency almost always leads to more resolutions. And you might be like, oh, well, I can understand how it would lead to more deflections, but increased latency tends to lead to more hard resolutions, right?
Interesting. Okay, I'd
Yeah.
love to unpack that a bit because I really like that you have these kind of two North Stars of like, we want more hard resolution, but we also want to ensure we're not losing soft resolutions by doing that, and you keep that ratio. I mean, it must mean that you have. I mean, frankly, I think there's a lot of people listening who maybe are a little jealous of like how strong of a data set you get in production here. So I would love to understand a bit more of that deflection rate and how that's all coming together.
The point of the latency thing is just, it's very unintuitive. You really need to measure in production. Like you would never build that latency signal, which confounds everything. You would never build that into your backtest, because suddenly like a longer answer might seem like it's got a higher resolution rate, but the reason it's got a higher resolution rate is because there's more latency before you serve it to the end user. More latency may increase the end user's perception of work that the bot
Oh,
has done.
fascinating.
And something you get a lot of confounding. And so over time you learn to tease out these confounders. But I really think there's two types of AI products. All models are wrong, some are useful. There's two types of AI product in the world at the moment. One is where it's like we have hand engineered our prompt with a data scientist to this specific business, to this sort of forward deployed engineer model. And almost everybody's doing that because you get a lot of accuracy quickly with that. And there's a second type of product, which is what we've invested in and we've built in, which is build this scientific system where you don't have to hand engineer it per customer. And if you go down that second route, well, you don't have to hand engineer it per customer. But I think the bit everybody misses is that means that the system, you now have this scientifically optimizable system that will get better and better over time. Whereas if you branch your prompts and you hand prompt per customer, you can't build this system that gets better and better over time. You just end up with like technical debt. You end up with like a slightly different prompt for every customer. And I think as we all know at this point, prompts like leak. If you make a change in one part of a prompt, it affects the performance of something somewhere else. And so you really want your prompts to be as standardized as possible. You want your systems to be as standardized as possible with well isolated, well encapsulated different pieces that can be tested, separately from each other. But always checking the overall system accuracy. And that's really what we've built. And I really think that over time, people are going to realize that you don't want the product that has been built for you by someone just like hand hacking the prompt. Like it seems great, right? On week one, it's like, oh, and I asked for this feature, and then suddenly they turned it around. Yeah, they did, but you're no longer on a standard product. And I think everyone would realize that if someone was like, yeah, I have this SaaS vendor and they made a great product for me. They branched the database just for me. Everyone would be like, oh, how are they going to maintain that? Well, they're clearly not going to maintain that. And so I think AI people have not made that connection yet. But yeah, we believe that in the long run, the future belongs to people who are building AI products, who are doing this sort of like a standardized, well-designed AI system that then has this level of like testing and rigor, and that it improves over time through scientific standardized testing. That's where we are placing our bets anyway. Hopefully it'll work out for us. But yeah.
Thanks to Galileo for sponsoring this episode. Their new 165-page comprehensive guide to mastering multi-agent systems is freely available on their website at galileo.ai and provides you the lens you need to understand when multi-agent systems add value versus single-agent approaches, how to design them efficiently, and how to build reliable systems that work in production. Download it for free at the link in the show description to discover how to continuously improve your AI agents, identify and avoid common coordination pitfalls, master context engineering for agent collaboration, measure performance with multi-agent metrics, and much more. I'd love to understand how this correlates to your team building strategy and kind of the stages with which you've continued to develop this approach. So obviously you move from this prompt focus to a post-training setup. What was the MVP for your post-training? Whereas, where are you today? And how is the team growing alongside of that? Because I think it'll be really informative for other AI leaders who are listening and thinking through, okay, how do I need to scale up my team? How should I be thinking through these stages of enabling, a much more scientific approach?
The scientific piece is really cultural, and it was in the team from the very start. In a previous role, I once worked for a company called Optimizely, A/B testing SaaS company, and so I've always sort of believed in like A/B testing and experimentation, and I think we really took that into the AI group, and so all our scientists will go and will run tests in production very fast and very rapidly, and are kind of responsible for checking and making sure. And when we interview, our interview loops always contain a lot about like, randomized controlled trials, the scientific process. We really want people to chat. We really want people to be coming to the team as scientists who are familiar with the core fundamentals of science. Because we use that day in, day out to make a better product for our end users. And so, we've ended up with a pretty technical structure in the AI group. Like we skew very tech heavy. Our scientists tend to be, they're mostly applied scientists. They'll be good at like, writing prompts. They'll typically have a background in machine learning. Often they'd have a PhD, master's in machine learning, 3 to 5 years of industrial work. See a lot of people have come in, maybe they've worked in recommender systems, things like that in the past, where you see a lot of that same sort of testing and mature development process. And then, we also have a large cohort of engineers, and the engineers are typically back-end engineers. We kind of draw about half of them from Intercom, half of them are new hires, and tends to be our most experienced kind of back-end and systems engineers, but who are then kind of like crossing into machine learning and AI as a discipline. So they've learned prompt engineering, and we've taught them prompt engineering. And then also, pretty common for them to be able to run an A/B test, interpret the results of that, able to like run a classifier, use scikit-learn to do some NLP stuff, or whatever we need to do. Again, or as the LLMs get cheaper and cheaper, they become our go-to tool more and more. But yeah.
And it also seems like you're doing a lot of context engineering, since I know you invested in RAG quite early. Talk to me a bit more about how that factors into this pipeline you've developed.
Yeah, I think we must have been one of the first production RAG deployments. Certainly, like we launched on GPT-4 launch day with GPT-4, and it was really like before GPT-4, when you tried to do RAG, it was very difficult to get the previous generation models to actually respect the RAG instructions reliably. So I remember when we launched Fin, I had made this decision to go this RAG direction. And we had a whole lot of competitors at the start who were just serving the naked model. And so they'd be like, hey, here's a chat bot, and we're just going to ask GPT 3.5 terabyte the answer. And sometimes it would get it right, and sometimes it wouldn't, And we were like, oh, this feels like a bad product. The business doesn't have any control over it. And I think we've seen people standardize on RAG, but we were certainly one of the first kind of production RAG deployments. And back in those early days, context engineering was a huge part of what you did. I mean, it still is, but I guess probably in the first year after Fin launched, so for a lot of 2023, we were really realizing how important it was to assemble the right context and pass it to the LLM. We probably spent a lot of time in early 2024 doing that as well. And we're now at the point where we have quite a complex, sophisticated pipeline for getting the right context into Fin. This starts with our chunking. We take all the content that Fin might possibly use. That content is chunked by LLMs. Then we go, and in production, we take the query the end user has. And as I mentioned, we kind of canonicalize that query. Then we have a custom retrieval model. It's a fine-tuned version of Snowflake, but fine-tuned on actual production resolution signals. Then we have a custom re-ranker model. It's completely custom re-ranker using ModernBERT as a building block. And those together are responsible for a lot of the accuracy of Fin. And when we built our custom re-ranker, we outperformed the best Cohere re-ranker at the time, which we were previously using. And we were really happy with that. And that was just because we have, I think, tons of high quality data of actually like, has this resolved the query or not. And we had to get our customers' permission in order to use that. And we did comms and stuff where we were like, hey, if you want to opt out of training here, you can. But I think, I, who would like it totally makes sense to me as a customer, not like, yeah, of course, a retrieval model, a re-ranker model. There's very little downside participating in that. And that makes the system better. So yeah, all of those things together really feed into this, I guess, this whole system that's responsible for providing, in our case, Claude Sonnet 3.5 or Claude Sonnet 4 with the right context that we need, and then with like a well-engineered prompt and a whole lot of other stuff that goes into that prompt, some of which is customer specific, where the customer has used our products to provide further guidance to it. And that's kind of that's how Fin generates its answers. And that's how we've been able to get such high quality answers.
And as you continue to build out your team over the next year, you're going to get even more human power to support building the system out. Can you talk a bit about the goals you have for taking a next step with Fin? And then conversely, I'd be curious what systemic risks you're seeing that you're paying attention to and trying to avoid from the start.
Yeah, I mean the second one is a hard question. It's a fast moving field. Like in terms of our goals, there's several big initiatives we have. One is we're building something we call Customer Agent, which we've publicly announced before, which is essentially that we think that the future here is not that you'll have different agents from different vendors all in the one conversation facing your end user, because that's just not going to be a good experience. They're going to like fight with each other. Will the sales agent from one vendor hand off to the customer service agent from the other one? There's going to be substantial overlap in terms of what they do, in terms of the systems they need to connect. We also don't see a good future of like some orchestrator agent that sits outside them and referees them all. That just feels like a pain. So we really see a world where to get good experiences, you really want one agent or one set of agents from one vendor that's like talking to your end users, one beautifully integrated system. And so that's really what we're trying to build. We call that Customer Agent. And so that means that we need to build roles for Fin. Fin needs to be able to act when the conversation is a sales conversation. It needs to be able to act when it's a customer service conversation, as it does today, and probably other things as well, like customer success. Probably needs to be able to act well in an e-commerce setting. And so, though that is one area of investment for us. There's the other investments we're continuing to follow through on. We have a pretty mature Fin voice product built using OpenAI's real-time API. I think we were one of the early customers of that API. Very good API for like low latency, high quality. We're now in like version, I think 4 of our kind of like tasks or procedures product, which is this product that like takes actions in external systems. It took us a while to crack that. It was always relatively easy to take actions. Fin from launch back in March 2023 could like call APIs, but they really nailed the product experience that made it easy for one of our customers to set up actions. Took a really long time. I feel we've just gotten there really in the last sort of like 6 to 9 months. We're starting to see real adoption and product market fit, and people now using Fin where it's like you say something to Fin and it takes an action that like opens a garage door in the real world or something like that. It's really quite cool. And people using it for very consequential real tasks. So we'll be following through of all those investments. We'll be following through our investment of continuing to invest in better and better AI models. And again, we've gotten good at post-training, and it's worked better than we thought. Like you can take an open weight model, and if you have enough data and you have the expertise, and it's a bit of work, you can get real benefits on your actual task. And again, when we beat Cohere's model at the re-ranking task, and Cohere, great company, and their model, we had previously done a big evaluation to find what's the best re-ranker we could, and we were using I think Cohere's re-rank 3. I'm misremembering the name, and then we trained our own re-ranker from scratch using ModernBERT and on a lot of data, and then even out of sample, even cross customer, it beat Cohere's re-ranker at this task. We were like, wow. And like it beat it substantially. We wrote a blog post on it. It beat it substantially, much more so than we expected. And we were like, wow, there's a lot of value to fine tuning for a specific task, or training from scratch for a specific task. And so we still believe that the future is probably vertically integrated AI products, and I think we're starting to see that. Like, I've been using Claude Code with Opus 4.5 recently, and it's just a great experience. And
Oh, completely agreed. The
yeah,
ability for Claude Code to set up its models, like, I mean, I've used Opus 4.5 with Cursor. It's a good experience, but having it within the Claude Code setup, it just seems to flow so much better together.
and like they are going to have post-trained or mid-trained Opus 4.5 in that harness. And so, and we see this, we basically see like there is absolutely a value to vertical integration where the model has been not just prompted, but being post-trained or mid-trained for the specific application. And like we see that there's parts of Fin that run way lower latency and way lower cost, like, 10x lower cost than we'd have been able to get by just prompting models. And there's other parts where we would never get the exact right trade-off. Like, we have like this is part, you you end up you trying to have a prompt that does a particular task, and then you realize it's doing the task wrong, so you put a special case in to stop it doing that wrong task, and that works fine for a while. Then you're in production for a while, you got like 50 special cases in your prompt, and you're overloading your prompt, and you just realize, no, I could like post-train these 50 special cases in, and then I wouldn't need to put them in the prompt anymore. My prompt is leaner and lighter. And so there's absolutely a value to that vertical integration. Is the value big enough to like carry the day and to be the thing that everybody cares about? I I don't know, but I do think you're seeing like people at the model layer. Obviously, like, thinking machines came out with this like API to kind of, and I think you're gonna see lots of people provide more and more interfaces. I think you're gonna see lots of frontier labs providing interfaces to like specialize and fine tune and post train. Would be my guess. Yeah.
I think this is also maybe an important point to highlight because one of the common questions in, I guess, the prior era of software is, why can't Google just do this? Why can't Microsoft just do this? And now we're again asking, why can't Google just do this? Why can't OpenAI just do this? What if their model just good? It's good enough. And the answer I think we're increasingly seeing is there's the unique data set angle of, look, we have this unique data advantage that others don't. And obviously that's been something that's been kind of talked about by the data and AI industry for 10 plus years, but we're really seeing that come to fruition now as models get better and better. But this idea of a vertical stack, a harness built for your task, is clearly starting to differentiate. And I mean, you have to stay on top of it. You have to continue to develop it. You can't, rest on your laurels. But it seems like there is a real case for defensibility that is arising with Fin and other, production use cases that have gone far enough down the road.
So I'll say a couple of things. I'll speak quite candidly here. I'll say a couple of things. I firstly say that something like Claude Code is a case for defensibility and verticalization coming from the model there, right? Which is that, like, given that you have the best model, no one else can build a harness that's as good for your model as you can. So like,
Yeah.
it's a way of the model there getting up the stack, right? And so like, that's quite strategically threatening if you're not a model layer company, right? And I've kind of been keeping an eye on Claude Code for a while as an exemplar of this. Great product. Okay, it doesn't necessarily mean that the vertical integration works the other way around. And so a company like us, we're coming from like up the stack, and then we're trying to vertically integrate to get the same defensibility, but coming from the top down. And so like, we have been doing stuff like, and I would say we have some real legitimate durable vertical integration and defensibility in Fin today.
I would
In
agree.
that, yeah, in that, like, all Fin, like, and I think, we do a lot of tokens in Fin. And when everyone was releasing their tokens recently, we canceled it up. We had like over 10 trillion tokens of Fin in production. So that's just in production. So we have a lot of tokens. And like, if we can make 30% of those, 50% of those using a lighter model, using our own custom model, cheaper, faster, better, I think it's great. It's real margin, it's real lower latency. And then we have now specific examples where you get better performance than we could possibly get by prompting. So I think we're starting to see it It's certainly the direction we're betting, and I'm betting that like we'll be able to create durable value for us and for our customers by vertically integrating in this way. But, weighed against that is like, it's the bitter lesson, right? Which is that like, okay, data, how much data do you really need to train the horizontal model? Often these things are quadratic. You get like, I don't know, you got to go like 10 times up more data to get like, 2 times more performance or whatever it is. And so, people climb that curve pretty fast.
Can I just
And
throw compute at it instead?
yeah, and yeah, so sometimes they can throw computer that are like, you can kind of get enough data to get to diminishing returns and more data pretty fast. We even see that when we do post training with Finn. You need a lot of data, but you don't need like, you don't need billions of data points. You can get pretty far with like tens of millions of data points, basically. And so, so I do think that the large model providers definitely do have a hand to play, and I think a really strong one. And so yeah, I do think that it's possible there's like still bitter lesson dynamics here, but we have a hand to play too. I think like vertically integrating. I think the open models, like intelligence will saturate for different tasks. Like for the RAG task of, here is a whole lot of data and I give the right answer to that question. You want to need a certain level of intelligence in order to do that, like a human customer support agent can do that. Like I don't know, a 100 IQ human or 110 IQ human is going to be like as good as a 140 IQ human basically at doing that task. Maybe better, who knows? And it's going to be the same for like the LLMs. Like you get to a certain point where like, yeah, the LLM is intelligent enough to do that specific task. And what matters now is about like the expertise, how it's tuned. Is it great at customer service? Has someone gone and tuned it to be absolutely great at customer service? And you can do that with prompting. You can get so far. We find you can get a little bit further with post training. And so, yeah, I think that there's some defensibility there. That's certainly something we're trying to do. We're also trying to go broad. We've got customer agent. We think there's going to be a lot of defensibility in terms of building something that is great at not just customer service, but at customer service, at sales, at customer success. I think we can build a unified horizontal agent that we think is legitimately the best in the world at those things. And that feels pretty defensible. I feel like you need a lot of expertise. And then you build a product around that too to make it easy to use, the reporting. That feels like a durable offering to us, or at least as best we can get. If someone comes out with a singularity or something, who knows what happens.
I mean, yeah, it's hard to plan for that.
It's hard to plan for that. But short of that, that's our strategic direction, and we've a lot of validation in the bet so far. So we'll see.
It's a really exciting story, and I appreciate you taking me through it kind of from inception to where you are today. It's been a super interesting conversation. And I honestly wish we had another half hour or an hour, because I feel like we had 3 other topics that I'd kind of bullet pointed out as like, oh, we should dive into this too. And, Fergal, you've been so fascinating on the post-training front and data pipelines that I know we're not going to get to everything. But I did want to ask a couple final questions here, because we brought up Claude Code, and I think you and I are both big fans of it. And my understanding is you were the first user of Claude Code at Intercom, and now it's integrated throughout your development pipeline, even, I believe, running autonomously on some bug tickets. Can you tell me a bit about that journey and what made you push for adoption company-wide?
Yeah. I don't remember exactly why I started to use Claude Code, but I saw that like Anthropic had released this new thing in beta. I checked it out, npm install, and it really kind of, it took me out for a week. Like every evening after the kids are in bed, I was like coding. I don't normally do a lot of IC work. I do a little bit, but not much. But I was like just coding with Claude Code, and I was like, holy cow, this thing is amazing. This is like
It's kind of joyful.
Yeah, it's kind of joyful. It felt magical, and I really spent a lot of time that week, like, awake at night after I was obviously code late at night. Awake at night, but thinking about the future of the software industry and like how horizontally disruptive it is going to be over time. And I reached out to the Anthropic team and was like slacking them. I was like, this is amazing. You built an amazing product here. And I think they featured me on like, I gave them a quote for the page. I think
That's cool.
they did something really cool with Claude Code. And I think it's an amazing product. And then when I went internally in Intercom and I did like an AI group all hands and I was telling people about it, some people like laughed at me. They were kind of like, "Oh, come on, we can do this already in Cursor." And some people thought we seriously. Some people laughed at me. Some people were like, "Oh, you're getting excited about it, but it's just the same as Cursor." And I think there's a lot of explaining because I know that like Cursor and the other IDs have done a lot of work to become more agentic since then. But like at that point in time, it's like, no, it's different. That when you put it in like the full auto dangerously skip permissions mode, which is like the only way to use it, like on a secure machine, hopefully. But when you do that, it just goes in a way that other things didn't. And so, I kind of had to go and take several people in the company and kind of like collison install, like install Claude code into them, like get them to sit down. Here's a laptop, look at this, check it out. I did that literally for one or two of the execs. And then that started the ball rolling. Okay. Once I kind of aligned those people and showed them the value of it, Intercom started an initiative to try and let's build a team responsible for taking this. This is going to change our space. And Intercom is really good. Our CTO, other people are really good at like, hey, let's be ambitious. Let's try it. Let's see how much we can get out of this. And so we ended up with like a good team of people whose job it is to make Intercom engineering faster overall. And then they started taking and roll with it and build agents that live as part of the Intercom system, the Intercom software engineering system, doing things like, automatically attempting to triage and identify the source of an issue when a customer submits an issue. And, it doesn't always work, but when it's a hit, it maybe saves time on like a critical issue that, where maybe minutes count in terms of, having a great customer experience. So yeah, it's been cool. It's been cool to see. And honestly, it feels like we're still just at the start of how these things are going to show up all over software.
Yeah, I think there's a lot of exciting stuff that's going to happen in the coming years around coding in particular, because we have just such an amazing data set for it with everything that's happened with GitHub. And then obviously there's so much focus on it. There's even like companies like Poolside, which we've previously had on the podcast. I highly recommend folks listening check out that episode with ISO and Jason Warren are the two co-founders. They're talking about how they think code is going to drive AGI. There's a ton of great stuff happening on coding. And I agree. I think Claude Code is really like a magical experience at times. And so it's a wonderful note to end on because I think it hopefully highlights the opportunity and the excitement and what's possible here. And Fergal, thank you so much for spending the time with me today. It's been such a pleasure chatting with you and really appreciate it.
Real pleasure, Connor. Thanks for having me.
And for folks who want to find out more about Fin, I believe fin.ai is the best place to go. There's a ton more there. Definitely recommend checking it out. Super interesting stuff that Intercom's doing here. And if you enjoyed this episode, we would love to hear from you, whether it's in the comments on Spotify. Let us know should we have asked Fergal questions we didn't? Should we have dove into topics we didn't cover? Or did you really love something we talked about? We'd love to hear from you. We'd love to know what your experience is like here too, because that customer feedback is also valuable to us. I'm not yet training a model off it. Maybe I should be, but I certainly am training my own mental model. So whether it's on YouTube, on Spotify, on LinkedIn, or DMing me on Twitter, or just adding me in publicly, even I'll take it. Would love to hear from you, listeners, and thank you so much for joining us today. And Fergal, one more time, I really appreciate it. Thanks for coming on.
Thanks, Connor.